Right now, a few hundred kilometers above your head, a satellite is going dark on purpose. It isn't broken. Nothing has gone wrong on board. The engineers who built it told it to do this. As it crosses one particular patch of sky over the Southern Atlantic Ocean, it powers its most delicate instruments down, folds its electronics into a kind of crouch, and waits to come out the other side. Because for the next few minutes, the thing that protects it, the thing that protects all of us, gets thin. There is a weak spot in Earth's magnetic field, a place where the invisible shield around our planet sags inward, almost down to the cloud tops, and lets the hard radiation of space press closer to the surface than anywhere else in the world. The people who study it have a quiet, half-joking name for the place. They call it the Bermuda Triangle of Space. It is real. It is measured. You could circle its location on a map. And over the last decade, two things have started happening to it that nobody fully expected. It is growing, and it is beginning to split in two. This is the South Atlantic Anomaly. To understand why a hole in something invisible should worry anyone, you first have to understand what that invisible thing does for you. Earth has a magnetic field. You've felt the tame end of it every time a compass needle swings to north. But the compass is the gentlest hint of something enormous. The field reaches tens of thousands of kilometers out into space, into a vast teardrop-shaped bubble called the magnetosphere, and it stands between you and the sun. The sun is not only light and warmth, it is also a constant wind of charged particles, and every so often a violent storm of them, moving at millions of kilometers an hour. Out in the open, that radiation strips the air off entire worlds. It's one of the reasons Mars is a dry, thin desert today. Earth has kept its atmosphere, its oceans, and its life for billions of years, partly because this magnetic field deflects the worst of that storm around us, the way water parts around the bow of a ship. You cannot see it. You will never feel it directly. But it is a large part of the reason you are here. So when geophysicists tell you there's a region where that shield has worn dangerously thin, and that the thin patch is getting bigger, it's worth asking exactly what they've found. Picture the magnetic field as a smooth shell wrapped around the planet. It was never perfectly smooth. Earth's magnetic axis is tilted about 11 degrees from the axis it spins on. Stranger still, the whole magnetic core sits off-center, shoved roughly 400 to 500 kilometers away from the planet's true middle. That offset makes the field lopsided. On one side of the world, it stands tall and strong. On the other, over South America and the Southern Atlantic, reaching toward the coast of Africa, it dips into a long, shallow valley. In that valley, the field drops below a level scientists use as a threshold, 32,000 nanotesla. Cross that line and the shield is weak enough to matter. At the very center of the anomaly, the field has fallen to barely over 22,000, and by some measurements it's still dropping. Here is the part that turns an abstract number into something physical. High above the Earth, there are two huge rings of trapped radiation, the Van Allen belts, particles caught and held by the magnetic field. Normally, the inner belt floats safely far overhead, but over the South Atlantic Anomaly, where the field sags, that belt of radiation sags with it, dipping down to around 200 kilometers above the ground. 200 kilometers is the height at which spacecraft fly. The anomaly is the one place on Earth where they fly straight through the radiation belt itself. This is why the satellites flinch. When a spacecraft passes through the anomaly, it's bathed in far more high-energy radiation than anywhere else on its orbit. A single particle striking the wrong circuit at the wrong moment can flip a bit of memory, corrupt a command, trip a sensor. Engineers call these single-event upsets, glitches written into a machine by the universe itself. The list of casualties is long and oddly specific. Laptops aboard the International Space Station have crashed as it crossed the zone. A SpaceX cargo capsule logged a strange transient over the South Atlantic on its way to orbit. A whole constellation of communications satellites suffered failures traced back to the radiation here. The Hubble Space Telescope simply gives up. Its most sensitive detectors can't take a single observation on any orbit that even clips the anomaly, which leaves only 5 or 6 of its roughly 15 daily laps of the Earth fully clear to do their most delicate work. One of the most powerful eyes humanity has ever built is partly blinded, every single day, by this one patch of sky. Even modern instruments built to expect it still feel it. A NASA laser mapping the world's forests registers a faint, anomalous blip about once in every million shots, and its power systems quietly reset themselves roughly once a month, every time the orbit carries it back through the weak spot. The astronauts who live up there have described seeing it with their eyes closed, cross the anomaly, and flashes of light bloom behind the eyelids, cosmic rays passing directly through the human eye, a reminder in the dark that the shield has thinned and something is getting through. For a long time, the anomaly was just a known hazard, a fixed bad neighborhood you learned to root around. Then we started watching it closely enough to see it move. In 2013, the European Space Agency launched 3 satellites called Swarm, flying in formation with one job: to map Earth's magnetic field in finer detail and over more years than anyone ever had. 11 years of swarm data have shown something unmistakable. The anomaly is expanding. Since 2014, the weak spot has grown by an area nearly half the size of the entire European continent. It is not a stable dent, it's a spreading one, drifting slowly westward across the globe, swallowing a little more sky each year. A wider, weaker patch of shield creeping outward, year after year, mapped not by theory but by satellites watching in real time. That alone would be a story. But the most recent data found something the older maps had only hinted at. In 2025, the team behind Swarm published its 11-year survey, and the anomaly, they reported, is no longer behaving like a single thing. It is dividing. A second center of weakness has been deepening off to the side, toward Southwest Africa. And since around 2020, that African lobe has been weakening faster than the rest of the anomaly. The single bruise on Earth's magnetic field is pulling apart into 2 distinct cells, each with its own behavior, each evolving at its own pace. The lead scientist put it carefully. The South Atlantic Anomaly, he said, is not just one block. It's changing differently toward Africa than it is near South America. There is, in his words, something special happening in this region. For years, a split like this was a forecast, a line in a model, a thing that might happen. As of 2025, it's no longer a prediction. The satellites are watching it happen now. So the field over the southern hemisphere isn't only weak, it's restless. It's reorganizing itself into a shape we've never measured before. To understand why, you have to follow it down, away from the satellites, into the part of this story we cannot see at all. Everything so far is happening at the surface. The cause is 2,900 kilometers beneath your feet. Earth's magnetic field is not a fixed magnet buried in the rock. It is generated continuously by an ocean of liquid iron, the molten outer core churning around the solid inner core in slow, colossal currents. That motion is a dynamo, and it has kept the field running for billions of years. But a dynamo built from turbulent fluid is never perfectly orderly. It has eddies. It has knots. Directly under the South Atlantic Anomaly, deep at the boundary where the core meets the rocky mantle, scientists have found one of those knots. They call them reversed flux patches, places where the magnetic field lines, instead of streaming outward like everywhere else, loop the wrong way and point back down into the core. Where that happens, the reversed field fights the main field and cancels part of it out. At the surface, far above, that cancellation shows up as a weak spot, as an anomaly. And the swarm satellites can now watch one of these patches crawling slowly westward beneath Africa, the deep engine of the split traced all the way from orbit. But why there? Why has the field chosen this one region, again and again, to misbehave? The best answer points to something enormous hiding at the bottom of the mantle. Beneath Africa, sitting on top of the core, there's a structure the size of a continent, denser, hotter, and stranger than the rock around it. Seismic waves from earthquakes slow down as they pass through it, which is how we know it's there at all. Geologists call it a large, low shear velocity province. Informally, it has a blunter name, the African blob. This buried mass may be the reason the anomaly keeps coming back. By disturbing the flow of heat and iron at the core's edge, the blob seems to encourage exactly the kind of reversed flux knots that thin the field above it. The weak spot over the Atlantic may be the surface scar of something that has been pressed into the deep earth for tens of millions of years, which raises the question everyone actually wants answered. A weakening field, a spreading hole, a buried mass disturbing the core. To a lot of people, all of that adds up to one frightening word: reversal. It's not a fantasy. Earth's magnetic poles really do flip. North becomes south, south becomes north, and the geological record is full of the evidence. The last full reversal happened about 780,000 years ago, and there are signs that could make you nervous. The planet's overall magnetic field has weakened by roughly 9% since the 1840s, and the magnetic North Pole has been racing across the Arctic towards Siberia so fast that the global models used for navigation had to be rewritten ahead of schedule. We even know what the run-up can look like, because it nearly happened recently. Around 41,000 years ago, during an event called the Lachamp excursion, Earth's magnetic field briefly fell to about 10% of its present strength. The shield didn't vanish, but it faltered. Auroras, which normally crown the poles, wandered down toward the equator. The amount of cosmic radiation reaching the atmosphere roughly doubled. For a few centuries, the sky itself would have looked and behaved like a different planet's. So is the South Atlantic Anomaly the first sign of the next one? Here is where the honest science pulls hard against the headlines. The scientists who study this most closely keep landing on the same careful answer. Probably not. The 2025 Swarm Survey, the most detailed look we have ever taken at the anomaly, found no sign of an impending reversal. And when researchers reconstructed the ancient field locked into volcanic rock, they found something that reframes the whole story. Anomalies like this one have appeared over the South Atlantic before, again and again, going back 8 to 11 million years. In other words, the weak spot is not unprecedented. It may simply be what this part of the planet does. A recurring feature tied to that deep blob, swelling and fading on a clock far longer than human history. A reversal, if one ever comes, would unfold over thousands of years, not in a single human lifetime. There is no countdown hidden in the data, so the anomaly is not the end of the world, but it is something almost stranger than the doomsday version. We tend to think of the ground under our feet as the very definition of solid, permanent, the one thing that doesn't change. The South Atlantic Anomaly is proof that it isn't. The shield that lets life exist on this planet is not a fixed wall. It is a living, shifting thing generated by a sea of molten metal that is still moving, still rearranging itself thousands of kilometers below the deepest hole we have ever dug. We can't see that engine directly. We may never reach it. The anomaly is the one place where its restlessness leaks all the way up to us, bright enough to blind a telescope, real enough to make a satellite flinch. It is the clearest window we have into the heart of our own world. And right now, through that window, we are watching something we have never seen before begin to pull itself in two. The satellites will keep crossing it, the instruments will keep flinching, and far beneath the southern Atlantic, in the dark where the iron turns, whatever is causing all of this will keep doing what it has done for millions of years, indifferent to the fragile magnetic shielded layer of life riding on the surface, watching the needle, wondering which way it will swing next. This is Nightside,